Moving on to extensive challenge question 1. Suppose that the diagram is to be completed such that writing each white square contains a different whole number from 1 to 12 inclusive, and the 4 numbers in the set of squares along each edge have the same total. So how many different ways can the diagram be completed correctly? All right, that's pretty easy. So you can see that I have 1, 2, 3, 4 line sums, and 3 of the intersections are already given, which means that I only have one unknown there, right? Let's say x. So it means that I have 4 totals, and that's going to be equal to 1 adding all the way to 12, adding 5, adding 6, adding 12, adding x. Right, so 1 adding all the way to 12 is 78. 78 adding 11, adding 12, that's going to be 101. So 40 is 101 adding x. And that's going to be divisible by 4, right? So it means that there are not too many options for x. X can be 3, but 3 is already taken. So x has to be 7 or 11, right? When x is equal to 7, it means that t is going to be 27. When x is equal to 11, it means that t is going to be 28. So let's try x equals 7 first. If x is equal to 7, it means that 3 adding 7 adding 5 is 15, which means that this has to be 12. And that's not fitting what we are asking for in the question, because 12 has been used twice there, right? So it means that this is not a valid case. Now we have to try x equals 11. Well, 11 adding 3 adding 5 is 19, which means that the empty blank has to be a 9 there. Now we have the numbers 1, 2, 4, 7, 8, and 10 remaining. And then, if you look at this edge, it's adding up to 17, which means that it needs 11 more in these 2 boxes. On this side, it also needs 11 more in these 2 boxes. And on this side, 12 adding 6 is 18. So we need 10 more in these 2 boxes. So, how can you find the 10 in these 6 numbers? Well, it's pretty obvious that the only number bond of 10 is going to be 2 and 8, right? Which means that 2 and 8 are going to be in some order in these 2 boxes. However, for 11, I have 2 sets of them, 1, 10 and 4, 7. So it means that first of all, I will have 2 ways to put the 2 pairs of 11s, right? It's either 1, 10, 4, 7 or 4, 7, 1, 10, right? So there will be 2 ways to arrange them already. And then after choosing one of the pairs, on each side, there will be 2 different arrangements. So 2 different arrangements between the 2 boxes, 2 different arrangements between the 2 boxes, and 2 different arrangements between the 2 boxes. So there will be 2 options on each side, which means that altogether, the number of outcomes is going to be 2 times 2 times 2 times 2, which is 16 ways altogether. All right? So that's going to be the answer to extensive challenges question 1.